Imagine you're walking along a shoreline at night and you notice something pulling itself out of the surf. It's armored, ancient-looking, with a domed shell, the shape of a helmet, a long, rigid tail dragging behind it, and a cluster of legs churning beneath. It looks less like something alive today, and more like something that crawled out of a museum diorama or out of a fever dream about prehistoric oceans. And here's the thing, that instinct isn't wrong. What you're looking at has been doing exactly this, pulling itself onto beaches, surviving, enduring for an almost incomprehensible stretch of time. That creature is the horseshoe crab. And it has a story that should honestly shake the way you think about life on Earth. People love to call the horseshoe crab a living fossil. They say it has refused to evolve, that it somehow cheated time, that it slipped through hundreds of millions of years of planetary upheaval without changing. Flip through enough nature documentaries and you'll hear it described as a relic, a leftover, a biological artifact that stumbled into the modern world by accident. And there's something undeniably captivating about that framing. The horseshoe crab does look strikingly similar to fossils pulled from rock layers laid down before the dinosaurs even existed. That's not poetic exaggeration, that's geology. But here's where the story gets genuinely interesting, because that phrase "refuse to evolve" is actually misleading in a way that reveals something profound about how evolution actually works. The horseshoe crab didn't stop evolving. Evolution never truly stops. It can't. Every generation mutations occur, environments shift, pressures change. What happened with the horseshoe crab isn't that evolution hit pause. It's something far stranger and more revealing than that. But we'll get to that. First, let's talk about just how old this animal really is. Because the numbers are staggering, horseshoe crabs are creatures built remarkably like them. First appear in the fossil record roughly 450 million years ago. Let that sit for a moment, 450 million years. For context, the first dinosaurs didn't show up until around 230 million years ago, which means horseshoe crabs were already ancient by the time T-Rex's ancestors took their first steps. Flowering plants didn't exist yet when horseshoe crabs were already a fixture of ancient seas. The continents were arranged in shapes that would be unrecognizable to us today. The world was, in almost every meaningful sense, a completely different planet. And then the extinctions came. Earth has experienced 5 major mass extinction events, catastrophic collapses of biodiversity that wiped out enormous percentages of all species on the planet. The most famous is the one that ended the dinosaurs 66 million years ago. But there's a bigger one, the Permian extinction 252 million years ago, that killed off an estimated 90 to 96% of all marine species. Nearly everything in the ocean died. The horseshoe crab made it through. It also survived the end Ordovician extinction, the late Devonian extinction, and the Triassic-Jurassic extinction. Each of these events reshaped life on Earth in fundamental ways. Each of them should have, statistically speaking, been the end of this animal. And yet, here it is, still pulling itself onto beaches. So what does a horseshoe crab actually look like, and why is it so recognizable across deep time? The body plan is distinctive to the point of being iconic. There's a large, rounded front section called the prosoma, that helmet-shaped dome, which houses the eyes, the brain, and most of the vital organs. Beneath it are the legs and a pair of small claws near the mouth. Behind the prosoma sits a smaller, more angular midsection, and then that long spike of a tail, called the telson, which the animal uses to right itself if it gets flipped over. The whole thing is encased in a tough, jointed exoskeleton that it sheds as it grows. Now go look at a 445 million year old horseshoe crab fossil. You'll see the dome, you'll see the segmented body, you'll see the telson. The proportions may differ slightly. The details will vary, but the fundamental architecture, the blueprint, is unmistakably the same. Across nearly 500 million years of geological time, through 5 extinction apocalypses, through the rise and fall of countless other species, this body plan persisted, and that's exactly why this creature matters so much beyond just being a cool biological curiosity. The horseshoe crab is a window. It offers us a rare opportunity to look directly at a question that sits at the heart of evolutionary biology. Why do some lineages transform dramatically over time while others seem to hold their shape? What does it actually mean for something to be stable? Is stability a sign of perfection, of luck, of some special relationship with the environment, or something else entirely? Most of what we learn about evolution comes from studying change. We trace how fish developed limbs, how reptiles grew feathers, how our primate ancestors gradually stood upright. Change is dramatic, change is visible, change tells a clear story. But the horseshoe crab forces us to grapple with the quieter, more counterintuitive side of evolution. What happens when change is minimal on the outside, even as evolution continues working beneath the surface? That tension between the appearance of stillness and the reality of ongoing biological process is where some of the most fascinating and contested ideas in evolutionary theory live. The horseshoe crab didn't refuse to evolve. It evolved in ways we're only beginning to fully understand. And unraveling how and why this animal's fundamental form persisted while the world transformed around it turns out to reveal something essential. Not just about this one strange armored creature, but about the nature of life itself, and the hidden forces that shape what survives and what disappears. So the real question isn't why the horseshoe crab looks the same. The real question is what we've been misunderstanding about evolution all along. So let's answer that question. What actually kept the horseshoe crab looking like itself across 400 million years of a changing planet? The concept you need here is called stabilizing selection. Most people learn about evolution as a story of directional change. A species gets pushed toward something new because a new trait helps it survive better. But selection doesn't always push things forward. Sometimes it holds them in place. When an organism's existing design already handles its environment extremely well, mutations that deviate from that design tend to get weeded out. Not because evolution stopped, but because departures from the winning form keep failing. Generation after generation, the body plan that works keeps working, and anything that strays too far from it gets eliminated before it can spread. Over millions of years, this creates something remarkable, a form that looks frozen in time, not because nothing is happening, but because the process keeps selecting for the same solution. And the horseshoe crab solution is genuinely excellent. Think about what this animal actually does for a living. It lives in shallow coastal waters and estuaries. It crawls along the seafloor eating worms, mollusks, and algae. It comes ashore once a year to breed on sandy beaches during high tides. That's essentially the job description, and it hasn't changed much. The habitat has shifted over geologic time. The specific coastlines have moved, but shallow marine environments have been a constant feature of Earth throughout horseshoe crab history. There have always been seafloors to scavenge. There have always been beaches to spawn on. The ecological niche, the specific role and lifestyle this animal occupies, has remained available and relatively stable across deep time in a way that many other niches simply haven't. That matters enormously. If the environment keeps presenting the same basic challenges, the same basic solutions keep winning. A heavily armored dome is still a heavily armored dome, whether the predators trying to get through it lived 300 million years ago or today. The telson still works for riding an overturned body, whether the water above it is a Devonian sea or a modern estuary. When the pressures don't fundamentally change, the adaptations that answer those pressures don't need to either. The horseshoe crab didn't dodge evolution. It found a niche that evolution kept rewarding it for occupying. But here's where it gets more interesting and where the living fossil label starts to crack. Because the horseshoe crab has been evolving, you just can't see most of it from the outside. At the genetic and physiological level, horseshoe crabs have changed considerably. Their genomes have accumulated mutations, their immune systems, their sensory biology, the molecular machinery of their cells, all of it has been quietly refined over hundreds of millions of years. There are also, importantly, 4 distinct species of horseshoe crab alive today. 3 in Asia, 1 along the Atlantic coast of the Americas. They are not identical animals, they diverge from each other, adapted to different regional conditions, develop different characteristics. That's speciation. That's evolution in the most classic sense. The external body plan looks similar across all 4, yes, but the living fossil framing collapses a complicated biological reality into a misleading oversimplification. The term living fossil, coined by Darwin himself, was always more poetic than scientific. It implies a kind of biological failure, as if these animals are primitive leftover mistakes that should have been replaced, but somehow weren't. That framing gets it almost exactly backwards. Calling the horseshoe crab primitive because it looks like its ancestors is a bit like calling a master architect's blueprint primitive because the house it describes has stood for centuries without needing to be redesigned. Persistence isn't failure, it's evidence of something that works so well it keeps passing every test the world throws at it. Surviving 5 mass extinction events is not the resume of a biological dead end. It is the resume of something nearly indestructible. And that resilience is genuinely astonishing when you hold it up against the timeline of planetary history. The oceans the horseshoe crab swam through 300 million years ago were chemically different. The oxygen levels, the temperature gradients, the composition of the water itself, all of it shifted dramatically across different geological periods. Continents moved, sea levels rose and fell by hundreds of meters. Ice ages locked up vast amounts of water and then released it. The world the horseshoe crab navigates today is not the world its ancestors first crawled across. And yet this animal kept adapting beneath the surface, kept adjusting its physiology and biochemistry to match whatever the ocean became, while maintaining the body plan that kept working in every version of that ocean. That combination, outward stability, inward flexibility, is one of the most underappreciated strategies in the history of life on Earth, which makes what's happening right now all the more urgent to talk about. Because the horseshoe crab, having outlasted virtually everything else on this planet, is now facing pressures that are genuinely new. Habitat loss along coastlines is destroying the beaches where they breed. Overharvesting has reduced populations significantly, which matters especially for migratory shorebirds like the red knot, whose survival is tightly tied to the calorie-rich eggs horseshoe crabs deposit on beaches during spawning season. And then there's the biomedical industry, which has discovered something extraordinary in horseshoe crab blood. It contains a compound called limulus amoebocyte lysate, or LAL, which reacts to bacterial toxins with remarkable sensitivity. It's used to test virtually every injectable drug and medical device for contamination. Every vaccine you've received was likely tested using horseshoe crab blood. Hundreds of thousands of crabs are captured each year, bled, and returned to the water, with survival rates after the process that remain a serious conservation concern. The animal that endured asteroid impacts and oceanic collapses is now navigating pharmaceutical supply chains and coastal development. That irony is almost too stark to process. So here's the takeaway, and it's one worth holding on to. The marvel of the horseshoe crab isn't that evolution stopped. Evolution never stopped. The marvel is that natural selection kept finding the same answer, kept returning to the same form, because the form kept being right. Stability in evolutionary terms isn't inertia, it's a verdict. And the horseshoe crab, ancient armored, quietly extraordinary, is one of the most emphatic verdicts nature has ever delivered.